In this video, we'll take a look at a couple more of the problems that were most missed on quiz number 1, and these are review. So number 2, 6 different second-year medical students at Bellevue Hospital measured the blood pressure of the same person. Hopefully these would all be the same. The systolic readings are listed below. Find the range, variance, and standard deviation for the given sample data. If the subject's blood pressure remains constant and the medical students correctly apply the same measurement technique, what should be the value of the standard deviation? All right, so the first item we want to look for is the range. The range is the maximum value minus the minimum value. So for our data set, we have 136 minus 122, which is equal to 14. So if all these medical students were testing the same person, they all look pretty good, except for the 136. And our range tells us that there's a pretty wide spread between values. All right, then we also want to find the sample variance and the sample standard deviation. The sample standard deviation we can find with the calculator, and then we take that value and square it to get the sample variance. So in your calculator, we take a look at the lists, edit, and we want to enter the values in list 1. Now this there's a video showing you how to do this, but we'll do this again. Oops. Need 122, 122, and then I want to make sure I entered those in correctly. So I've got 122, 123, 36. Okay, so we're good. So once you get items in the list, you go to, I usually try to quit so I don't change my lists. Go to Stat. We want to calculate one variable statistics. Our items are in list 1, so it automatically selects list 1, but if you ever want to choose a different list, you can choose the list numbers here. This tells us that the sample standard deviation, Sx, is 5.6. It does tell us to round to the nearest tenth is needed, so 5.6. This does not give us the variance, so you have to take your value, the 5.648, and square it to get the variance. So you have to find the standard deviation first. So standard deviation, which is small case s, was equal to 5.6. And then to get the variance, we're going to take the non-rounded, let me go back here, the 5.648. I'm just going to take the first 3 digits because that seems like, since we have zeros. So take 5.648 and square it. So I'm going to clear and take, 5.648, square it. So my value estimated for the variance would be 31.9. Okay? So that's the 31.9. So the calculator will not give you the sample variance, it's the standard deviation squared. Okay, next, oh, and by the way, these are, I didn't label them because they're here, labeled in whatever your units are that you're using. All right, number 3. This is on range rule of thumb. Below are the range and standard deviation for a set of data. Use the range rule of thumb and compare it to the standard deviation listed below. Does the range rule of thumb produce an acceptable approximation? And then suppose a researcher deems the approximation as acceptable if it has an error less than 15%. So the range is 2.95. The standard deviation is 0.801. What the rule of thumb is, there's actually 2 range rule of thumb. One of them you use pretty often in chapter, probably, well, they mention both of them in here. We'll use it quite a bit throughout the course. One range rule of thumb is taking an estimate for your measurement to be your mean plus or minus 2 standard deviations. There's a second part to that, and it's on page 101. The second part is to approximate the standard deviation. And the standard deviation is approximately the range divided by 4. and that's a range rule of thumb. So our range was 2.95. Divide that by 4 to estimate, and we want to see how close we get. So I'm going to get the calculator. 2.95 is equal to 0.7375. And then if we want to, that seems pretty close actually, not too bad. If you want to know if that's within the 15%, the error is you take the actual minus your estimate and then divide that number by your actual. And that will tell you what percent error you have. So let me do that on the calculator. The actual value was 0.801 minus the 0.7375. So the difference between the two was 0.0635 divided by the actual, which was 0.801. Okay, and if that's 0.07, move your decimal to the right 2 places to change it to a percent or multiply it by 100. So we're 7.9% off. So if our error is less than 15%, which it is, then that means that's an acceptable approximation.